Hello Year 10, hopefully you had a lovely Easter break and spent time with your families. We're going to start going through the next pack, which is Algebra 3H now, and we're going to start with factorising and solving quadratics. First we're going to practice just the skill of factorising, and then we'll come to the solving a bit later. So first off, when we're trying to factorise, we're trying to put it back into brackets, in terms of algebra anyway. We could write a number factorised, so for example the number 24 we could write as 8 times 3, for example. So that just means writing it as a product of two factors, and that's all factorising means here. It just means writing this expression as a product of two factors. So how do we do it with quadratic expressions like this? Well, first off we need to think about what were times together in these brackets to give us the first term, x squared. And that of course will be x times x. Now the shortcut to finding the other two numbers in the brackets is to look at your coefficient of x and your constant at the end. Okay, so the two numbers here and here will times together to make this number at the end, the constant, so they will have a product of 4, and they will sum together to give the coefficient of x. Okay, so they will add together to give 4. So you're looking at two numbers that times together to make 4, add together to make 4. So in this case it's going to be plus 2 and plus 2. Okay. Now we could also write that as x plus 2 all squared. Okay, on the second one, again it's going to be a double bracket. With an x and an x at the start of the brackets. You'll notice that pretty much all of these have just an x and an x at the start of the bracket. In fact, I think all of the ones on this page do, yeah. And when we looking for the other numbers, they're going to times together to make 4, but this time add together to make 5, positive 5. So times together to make 4, but don't add together to make 4 like the previous question. Well, that's got to be 4 and 1. It's the only other pair of numbers that times together to make 4, and when we add those numbers they make 5. On the third one it's going to be x and x, of course. Now looking for two numbers that times together to make 6 but add together to make 5. So this is always where I start. If I'm not sure, I'll write down the options. So I've got 1 and 6, that would be one pair. Now they wouldn't add together to make 5. The other option is 2 and 3, and they would add together to make 5. Okay, so I'm going to finish this first question off, pause the video here, and then restart once I've done them all, and you can mark them, and then I'll move on to the next one. Okay, there's the answers to question 1. Moving on to question 2. The only difference here is that we've got some negatives involved, and I'll show you what difference that makes. So on this first one, we're again looking for two things that times together to make x squared, so that'll be x and x. Now this time we're looking for these two other numbers in the brackets to multiply together to make negative 12. So I know one of them has to be positive and one of them's got to be negative straight away. So it's the only way I get a negative product. And I'm looking for them to add together to make the coefficient of x. Okay, not x itself. So the coefficient, the number in front of x here is 1, positive 1. So factors of 12 first of all, 1 and 12. 2 and 6, 3 and 4. Which of those pairs can I add together to get positive 1? And that will be positive 4 and negative 3. I personally don't even think about negatives really, usually, until I'm considering this number here, what they have to add together to make. So I look at my pairs and I think the only way I can make positive 1 is to have a negative 3 and a positive 4. Okay, on the next one. X and x at the start of my brackets. The numbers again multiply together to give 12, so that's 1 and 12, 2 and 6, 3 and 4. In fact, I'm going to stop writing this out every time because these are all 12 in this question. Now I want them to add together to make negative 1 this time, and that's going to be negative 4 and positive 3. Okay, so the signs swapped around. On C, I'm going to put my x's in the brackets first. This time I want them to add together to make positive 4. So I'm looking back at those pairs, and these ones are the only ones I can make positive 4 out of, and I'm going to do that by having a positive 6 and a negative 2. 6 take away 2 would be positive 4. Okay, on D, I need them to add together to make negative 4, so that's going to be the opposite way around. I'm going to have a plus 2 and a minus 6, and hopefully you can see why that makes negative 4. These ones have to add together to make 11, so that's going to be plus 12 and minus 1. And finally, minus 11 is going to be plus 1 and minus 12. It doesn't matter which bracket your plus goes in. As you can see on this question, I put it in the second bracket. On this one, I put it in the first bracket. It really doesn't matter. Okay, the next question is very similar, but the final term is positive. So x and x in each bracket, two numbers at times together to make 36. Well, these are all 36, so I'm going to write down my factors of 36 over here. So I've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Quite a few factor pairs there. On this first one, part A, they add together to make 12, so that's going to be plus 6 and plus 6, and you can also write that as x plus 6 in brackets all squared. Good shortcut. And the second one, they are going to add together to make negative 12, so this is going to be minus 6 and minus 6 in each bracket, and that would still give us a positive product, okay, because two negatives times together gives us a positive. We could also write that as x minus 6 all squared. On part C, whoops, part C, they're going to add together to make negative 13. So I'll just have a look at my factor pairs. Which one's going to make 13 with? Forget the negative for a minute. Those are the ones I can make 13 with, 4 and 9. So I've got x with a 4 and x with a 9. Now how do I make it negative 13? Both numbers must be negative. It's the only way I can make negative 13. And the final one, I'm sorry, and I'll just look back at that one actually and just explain that the two negatives times in together would give me a positive product. So that all works fine. On the final one, I want them to add together to make negative 15. So looking at my pairs, I can see it's going to be 3 and 12. So it's going to be x minus 3 and x minus 12. Number 4. This is where we're first introduced to solving quadratics using factorized form. Now the whole point of this is to be able to solve a quadratic equation, so an equation with an x squared in it. Okay, you can see in question 5 that's what they look like. They don't look like that in question 4, and that's because they've already been factorized for us. So question 4a, they've already given us a quadratic, it is a quadratic, but it's already in factorized form. Now remember what I said at the top about factorized form, just meaning written as two things being multiplied together to give that answer. Now what two things could be multiplied together? Bear in mind there's an invisible multiply sign here to give us 0. Well, it could be 0 and something, or 0 and 0, but the point is we've got to have 0 there, haven't we? Okay, so we have to set each of these brackets equal to 0 and figure out what x was to make that bracket 0. So if this first bracket was 0, x minus 1, if that was equal to 0, then what must x have been? Well, we could solve this equation to find it. We could add 1 to each side, and that tells us that x must have been 1. If you think about that, subbing that back in, 1 minus 1 would be 0. If this second bracket was the one that was 0, then we'll set it equal to 0 and solve it. What must x have been? Add 3 to both sides, x must have been 3. And in fact, both of these are the solution to the question. Quadratic equations often have two solutions. They can just have one. They can also have none. But if you're asked to solve a quadratic equation, most of the time it'll have two solutions. This is them. Okay, on the next one. If the first bracket is 0, then x minus 4 is 0, so x must be 4. And the second bracket, x must be 9. Okay. Quite soon you'll start just looking at brackets and thinking that x must be the opposite sign of whatever number this is. And most of the time you'll be right. Just be careful in using that approach when we don't just have one x here. Okay. Right, so for part C, x must be -1 to make this first bracket 0, and -6 to make this second bracket 0. Just going to start writing the solutions now. X is 3 and x is -2 on part D. On question 5, we have to now just add in that extra step of factorising first. So just going to rub that out. Okay, so we've got to write the factorised form. They just shaved off one step in the previous question. So numbers at times together to make 8. I've got 1 and 8, 2 and 4. And to give me a sum of 6, it has to be the 2 and 4 pair. Doesn't matter which way around they go, they're both positive. And if this bracket is equal to 0, then x must have been -2, and x must be -4 in the other bracket. Okay, I'll just do one more and then leave the rest for you to do. So here my numbers times together to make 12 and add together to make 7, so that's going to be 3 and 4. And I always write the equals 0 bit as well when I'm doing these, just to remind myself that this is an equation to be solved, not just one that we're factorising. Whoops. Okay, so x must be equal to -3 and -4. Okay, I'm going to pause the video now and complete these. You have a go, pause it here yourself, and then you can check your answers in a second. Okay, there's the answer to question 5. On to question 6. The only difference with these quadratics that we have to solve is that they are not equal to 0. So one thing you'll learn quite quickly about solving a quadratic equation is that it needs to be equal to 0 before we can do it. So to make this first bracket equal to 0, what I need to do is add 1 to both sides, and that will make this term over here 0. And it's important also to keep your x squared positive. So it's on the right side as it is. Just going to add 1 to this side, and that will give me x squared plus 2x plus 1 equals 0. Now I can factorise this as above, and that will be x plus 1, or x plus 1 all squared, and therefore x must be equal to -1. And this is one with a duplicated root. So like question 5, I've just realised it says 5c over here, but that, yeah, that's a similar sort of question. Okay, part B, I've now got to get rid of 2 things to make that side equal to 0. I want that side to be equal to 0 because I've got a positive x squared term over here. So I could do this in 2 steps. I could also do this in one combined step as well. So what I'm going to do is take away 7x and also add 12 all in the same step. And that will give me x squared minus 7x plus 12 equals 0. And then I can factorise and then solve. So that will be -3 and -4. So x is equal to +3 and +4. And what you'll find later on is that these solutions represent where the quadratic graph crosses the x-axis. And finally, part C looks really complicated. I already have my y squared term positive on that side of the equation, so I'm going to leave it there. I'm going to get rid of these so that there is 0 on this side, and I'm going to do that by taking away 3 and adding 7y to both sides. And that will give me y squared, because that wasn't affected. If I add 7y to 6y, I'm going to have 13y. And if I take away 3 from 15, I'm going to have 12. And then this will factorise as y plus 12 times y plus 1. So therefore y is negative 12 and negative 1. And that question carries on, so I'll let you do the rest. I'll go through the rest of the question on the next video.